Okay, so this one is on matrices, and this one is also from the international A levels, and this one's fairly easy. It's quite basic as well, but I have to explain it anyway. So part A is to find possible values of k. So the obvious one out of the window is that I'll need the determinant of m minus lambda I. So I'm sure anyone with a brain would know how to find that determinant. So I'm gonna skim through this very quickly. Oh, that should be okay. And this baby is just this determinant. Oops, sorry. And we have this expression here. And then we just expand everything because we need to. Oops. And we group the terms in terms of lambda because I want a function of lambdas, so it will be easier. That's 18. Yeah, that's 18. Minus 107 plus 4. 190. Oops. Squared, and when 3 is an eigenvalue of m, so we could say this is true. We could just say this is true, which means this thing is 0. And this one is quite annoying. So that's 4k squared equal to 3 squared 9. 18 times 9 is 162 minus 27. So that's 140 minus 135. 135 minus that monstrosity plus 90. So that should be 325 minus 309. So it's 16, which means k is positive or negative 2. And that's it for part A. Quite easy. Part B says that k is less than 0. Oh, well, from that onwards. So we could say that k is negative 2 now. So we need to find other eigenvalues of m. So obviously we have to simplify f lambda again. Which means we have this function that's 4. So that's 4 lambda minus 28. And then we need that equal to 0. So let's factorize that very quickly. One of the factors is lambda minus 3 because 3 is an eigenvalue. So now we just do long division, and I think anyone with a brain could do that. So that's and sorry about that. That should be, yeah, that's a plus. What am I doing? So that's a plus. So 54. And then minus 54. And 54 times 3 is 162. So now we have this function. So we could confidently say this is the case, and if this is 0, this implies, or 9 says six and 9 are the other eigenvalues. And C, we need a normalized eigenvector for lambda equals 3. So we could say, and then, well, I can't remember the matrix. Wait. Oh, okay. So it's M, so definitely I did it correctly. And then that's km5 minus lambda. Hold on. km5, so km5 which means we have is equal to right hand side, which implies alpha is equal to beta, and negative 1 over 2 alpha is gamma, which implies 6 alpha minus 2 alpha minus alpha is 3 alpha, which implies alpha can be any real number, which implies x can be the following combinations, and which means we need modulus of x. And which means the normalized eigenvector required is equal to 1 over the length of, which is the modulus of x, and then 1, 1, negative 1 over 2. And that's it for this question. Very simple.